Good morning, students. In previous class we have learned how to calculate the composition percentage, how to calculate the molecular formula as well as empirical formula. Now we will discuss about chemical reactions and stoichiometric calculations. Today our topic is the topic. First of all, before entering into our topic, we have some example. For example, 2 cups of rava is used to make a preparation of 3 cups of halwa. So here 2 cups of rava as well as 1 cup of sugar will be added to prepare the 3 cups of halwa. Okay, so here the numbers which are these 2 cups and the 1 cup and 3 cups, so which are called coefficient. So these are the numerical values which are quantity. So these coefficient can explain the quantity of reactants as well as the products. So from this we can explain that stoichiometry can explain the quantitative relationship between the reactants and products in a balanced chemical reaction. So these are called quantities. It is also called reaction coefficients. Okay, the quantities of a reactants as well as the products can be expressed in moles or masses or volumes. Okay, for example, we take a general reaction. That is a combustion reaction of methane. So methane combustion reaction is nothing but methane gas is reacted with the 2 moles of oxygen gas to form 1 mole of carbon dioxide gas plus 2 moles of water. It is also in the presence of gases, that is a vapor state. Okay, so this is a balanced chemical reaction because reactants, how many number of, that means number of reactants is exactly equal to number of products. So this chemical reaction can explain the quantitative relationship between the reactants and products. So how can it explain the balanced chemical reactions? For example, we take in terms of, whenever the reaction is expressed in terms of molecules, we can say that one methane molecule is reacted with 2 oxygen molecules. So one methane molecule is reacted with 2 oxygen molecules to give 1 carbon dioxide molecule and the 2 water molecules. So it is a balanced chemical equation whenever this equation is expressed in the molecules. For example, here we know that these quantities can explain the moles, masses as well as the volumes. Okay, so now according to moles, we can say that 1 mole of methane gas is reacted with the 2 moles of the oxygen to form a 1 mole of carbon dioxide plus 2 moles of water will be formed. Okay, so according to moles. Next, according to masses, we can say that, so total molecular mass of the methane is 16. So 16 grams of methane is reacted with 64 grams of oxygen to form a 44 grams of carbon dioxide and 36 grams of water will be forming according to masses. Next, according to volume, we can say that 22.4 liters of methane gas is reacted with 45.4 grams of oxygen to form 22.4 liters of carbon dioxide. Isolate the 45.4 grams of 4 liters 4 liters of water vapor will be forming. So this is the expression as a the quantities is expression in moles. So here the quantity are expressed in masses is nothing but grams. Here the quantities are expressed in volumes. Okay. So now these three units are which are moles, mass and volume. These three units are interconvertible like this. Okay. You will easily remember that this is a number of moles, it is a mass and the volume. These are the interconvertible, and one chart will be given. I will give the one chart and you will easily convert the moles to number of moles and masses like this. Okay. If the masses are converted into number of moles, the number of moles are converted into volume. Okay. So here interconvertible, and the volume is converted into number of moles, and the number of moles are converted into grams is nothing but masses. So whenever we change the moles in mass is converted into number of moles, we divide it by molar mass. Okay. If the number of moles are converted into volume, so we multiplied the 22.4 liters. We multiply the number of moles multiplied with 22.4 liters, we got a volume. Occupy the volume. Okay. So now volume is converted into number of moles, just divided by 22.4 liters. Now here number of moles are converted into masses, that means multiplied with molar mass. So this is the easy chart. You remember that, or from this we can convert it easily from one parameter to another parameter. M is masses, N is the number of moles, V is gas occupied by the volume. So next one is we will see the limiting reagent. So now what is the limiting reagent? The definition of the limiting reagent, that is the reactant which gets completely consumed and limits the amount of the product formed is called limiting reagent. That means in the reaction, that reactant is completely consumed. That will completely consumed and it will limit the formation of the product. It will limit the formation of the amount of the product is called limiting reagent. For example, here best example we take before the example, that is 2 cups of rava is required plus 1 cup of sugar. We will make the 3 cup of halwa. So from this we can say that 1 cup of sugar will be needed for the 2 cups of rava for making the 3 cups of halwa. So here available of the here 8 cups of rava and 3 cups of sugar will be available. Okay, so from this we can find that So which one is a limiting reagent? That is our task. Okay, so actually in general what is it, 1 cup of the sugar is needed to 2 cup of rava, we make a 3 cup of halwa. Okay, so here for example 3 cups of sugar. So 3 cup of sugar means how many requirement? If the multiplied the all one is a 3, so here is also 3. So from this we can say that that is a 6 cup of rava and 3 cups of sugar mixing to form a 9 cups of halwa. Okay, so here from this 3 cups of sugar is reacted only 6 cups of rava, we make a 9 cups of halwa. So 8 minus 2 means remaining 2 cups of rava is remaining. Okay, so here which one is a completely consumed? 3 cups of sugar is completely consumed, and here is also how many lefts are 2 cups of rava will be left, because 3 cups of sugar will make or required only 3 cups of rava, but the remaining 2 cups of rava will be remaining. Okay, so that's why here, so there is a no reactivity, there is no participated in the reaction, because here there is no sugar is there. If the sugar is there, this rava can reacted with the sugar to form a halwa, but here sugar will be completely consumed, rava will be remaining left. If ఇది ఉన్నా కానీ ఏం చేయదు, ఎందుకంటే మనకి షుగర్ కంప్లీట్గా అయిపోయింది కదా. సో దట్స్ వై హియర్ లిమిటింగ్ రియేజెంట్ ఈజ్ ఏ షుగర్. సో షుగర్ ఈజ్ కాల్డ్ లిమిటింగ్ రియేజెంట్. And here rava is called excess reagent. Excess reagent. Okay, so here you will see that according to the definition, according to sugar, here the reactant, that means sugar which gets completely consumed, that means that if the 3 cups of sugar is given, it's a completely consumed, and this will limit the, so it limits the formation of the or amount of the product formed. Okay, so ante manaki ee sugar paina depend ayi halwa anedi, the amount of the halwa depend ayindi. Ikkada manaki రవ్వ ఎక్స్ట్రాగా ఉంది, 2 cups ఆఫ్ రవ్వ ఎక్స్ట్రా ఉంది, బట్ అయినా షుగర్ అనేది కంప్లీట్గా కన్జ్యూమ్ అయిపోయింది, కాబట్టి ఇక్కడ అమౌంట్ ఆఫ్ ది ప్రోడక్ట్, దట్ ఈస్ హల్వా ప్రోడక్ట్, ఈ విల్ బి నాట్ మోర్ దెన్. ఓకే, అంటే మనకి రవ్వ ఎక్స్ట్రా ఉన్నా కానీ ఇక్కడ హల్వా అమౌంట్ ఆఫ్ ది హల్వా ప్రొడక్ట్ కావట్లేదు, బికాస్ లిమిటింగ్ రియేజెంట్ అన్నది కంప్లీట్గా కన్జ్యూమ్ అయిపోయింది. ఓకే, సో దట్ ఈస్ కాల్డ్ లిమిటింగ్ రియేజెంట్. ఐ హోప్ you understand. Okay, so now our task is, if the reaction is given from this, which one is a limiting reagent? That is our task. So this is a limiting reagent. Find out the limiting reagent is very very important. So that's why I explain once again in Telugu. Okay, so here మనం ఎన్ని కప్పులు అంటే 2 కప్పుల రవ్వ 1 కప్పు షుగర్ తీసుకున్నాము. సో దీంతో మనకి 3 cups of హల్వా will be prepared. ఓకే, సో మనకి ఎంత అవైలబుల్ ఉంది? 3 cups of షుగర్ అవైలబుల్ ఉంది అండ్ 8 cups of రవ్వ కూడా అవైలబుల్ ఉంది. కానీ మనకు యాక్చువల్గా ఎంత అవుతుంది? 3 cupsకి 6 cups రవ్వ కలిపితే మనకి 9 cups హల్వా ప్రొడ్యూస్ అవుతుంది. అంటే ఇక్కడ మనకి 2 cups రిమైనింగ్ ఎక్స్ట్రా ఉంది, అయినా కానీ షుగర్ అన్నది కంప్లీట్గా కన్జ్యూమ్ అయిపోయింది కదా. సో అందుకే మనకి హల్వా అన్నది ప్రొడక్షన్ ఉండదు. సో దట్స్ వై హియర్ ద షుగర్ ఈజ్ కాల్డ్ యాక్ట్ ఈజ్ ఏ లిమిటింగ్ రియేజెంట్. ద డెఫినేషన్ ఈజ్ చూస్తే కూడా ద రియాక్టెంట్ విచ్ గెట్స్ కంప్లీట్లీ కన్జ్యూమ్డ్ ఇన్ ద రియాక్షన్, అంటే అది కంప్లీట్గా కన్జ్యూమ్ కావాలి. నెక్స్ట్ అది ప్రోడక్ట్ ఫార్మ్డ్ అమౌంట్, అంటే ఆ ప్రోడక్ట్ యొక్క అమౌంట్ని అది లిమిట్ చేస్తుంది. అంటే ఆ లిమిటింగ్ రియేజెంట్ ఉంటేనే ప్రోడక్ట్ ఫార్మేషన్ అనేది జరుగుతుంది. ఒకవేళ లిమిటింగ్ రియేజెంట్ అనేది కంప్లీట్గా కన్జ్యూమ్ అయిపోయింది అనుకోండి, మనకి ప్రోడక్ట్ ఫార్మేషన్ అన్నది ఉండదు. సో ఐ హోప్ యూ అండర్స్టాండ్. In the next example, so this is also applicable for the reaction. So for example, here 2 moles of nitrogen monoxide is reacted with oxygen to form a 2 moles of NO2. Okay, but the available, that means given 8 moles of nitrogen monoxide given and the 7 moles of the oxygen is given. So from this we can find out that, so which one is a limiting reagent. Carefully seeing. Okay, so here the 1 mole of oxygen is reacted with 2 moles of nitrogen monoxide to form the 2 moles of nitrogen dioxide. That means 1 mole of the oxygen is required, 2 moles of the NO. For example here you will multiply the 7. So how much here? And here is also 7, here is also 7. So how much? If 7 moles of the oxygen is requiring 14 moles of, or 7 moles of the oxygen reacted with 14 moles of the nitrogen monoxide to form 14 moles of the NaOH. That means 7 moles of the oxygen is reacted with how much? 14 moles of the 7 moles of the oxygen is reacted with 14 moles of the nitrogen monoxide to form 14 moles of the nitrogen dioxide. But in our problem the given amount is 8 moles. That means very less mole. That's why here NO is acting as a limiting reagent. So this is a limiting reagent. Okay, next one is, if another one is sulfur is reacted with 3 moles of the fluorine molecule to form a sulfur hexafluoride. How many coefficients are? 1 mole of sulfur is reacted with 3 moles of fluorine to form a 1 mole of sulfur hexafluoride. But in the problem is 3 moles are given as well as 12 moles are given availability. So from this we can find out that which one is a limiting reagent. So here which one is limiting reagent? Nitrogen monoxide. Okay, so now come to the problem. Okay, so here according to balanced chemical equation, so 1 mole of sulfur is reacted with 3 moles of fluorine to form a 1 mole of sulfur hexafluoride. If it is a available of 3 moles, that's why it is a multiplying with 3. It is also 3. It is also 3. That means 3 moles of sulfur required how many? 9 moles. 9 moles of fluorine to form a 3 moles of sulfur hexafluoride. So in the problem, how many requirement here? Only 9 molecules are requirement, but how much? The 12 moles of the excess. Here it is a excess reagent. Okay, so it is a excess reagent. Because only according to the sulfur 3 molecules is the requirement of the 9 molecules of the fluorine is enough to form the 3 moles of the sulfur hexafluoride. But here in the problem 12 moles are given. That means 3 moles are excess. That's why here it acts as a excess reagent, and the sulfur can act as a limiting reagent because it is a completely consumed in the reaction, and it will limits the production of the product. So this is called limiting reagent. Okay, so I hope understand from these 3 examples. Once again repeated, the limiting reagent, it is a completely consumed and it limits the amount of product formed. So in your book is also one of the problem is given. Now we find out the problem. You see problem 5.5. In this 50 kg of nitrogen gas will be given, and it is reacted with 10 kg of hydrogen gas and to form ammonia. Now here calculated, first one is calculated the amount of the NH3, and the second one is identify the limiting reagent. The limiting reagent or reactant. So this is our task. So which one is given? The amount of or quantity is given. Quantity of nitrogen as well as quantity of hydrogen will be given. And you should remember that whenever find out the limiting reagent, reactant quantities are different. Okay, if reactants containing the different quantities, we can find out the which one is, that means we can find out the limiting reagent. If the both are same, we cannot determine the limiting reagent. That's why you also found that in before reaction is also different quantities of or different reactants are participated. So first of all, whenever we find out the limiting reagent, first write the balanced chemical equation. That is a nitrogen is reacted with 3 moles of hydrogen to form 2 moles of ammonia. Okay, so 1 mole of nitrogen is reacted with 3 moles of the hydrogen to form 2 moles of the ammonia. It is a balanced chemical equation. 2 nitrogens are there, 2 nitrogen, 6 hydrogens, 2 into 3 is 6 hydrogens. Okay, so from this, which one is a availability? Actually, so according to mass, we will write according to mass, that is a 28 kg of nitrogen is reacted with 3 kg of hydrogen and to form 34 kg of ammonia. According to, we will write the according to kgs. So now whenever we find the limiting reagent, if the sometimes grams or kgs, mass is converted into, first step, mass is converted into number of moles. Mass is converted into number of moles. So here first of all we find out the nitrogen moles. So from this nitrogen moles, how much the given in is a 50 kg. So we know that 1 kg equal to 1 kg equal to 1000 grams. Next, molecular weight of the nitrogen means nitrogen molecule is 28 grams of nitrogen containing the 1 mole. So from this we can calculate the moles, number of moles. Kg cancel, and the grams cancel. Now from this we got a 17.86 into 10 to the power of 2 moles, nitrogen moles. Next one is hydrogen moles. So that is also 10 kg is given. So that means 1 kg equal to 1000 grams into, so approximately 2, but we reference it as 2.016 grams of hydrogen containing the 1 mole. 1 mole of hydrogen. Now grams cancel, kg cancel. So we got the value that is 4.96 into 10 to the power of 3 moles. Okay, so from the reaction it is a equal balanced chemical reactions. So 1 mole of nitrogen give 1 mole of nitrogen is reacted with 1 mole of nitrogen is reacted with 3 moles of the hydrogen. Now how much is given? Nitrogen 17.86 into 10 to the power of 2 moles of the nitrogen. How many moles of hydrogen is given? So direct I will write the value, that is a 5.36 into 10 to the power of 3 moles of hydrogen will be required. If the nitrogen is completely consumed to form a ammonia, how much the requirement of the hydrogen? That is 5.36 into 10 to the power of 3. But actually in the problem how much is given? 4.96 into 10 to the power of 3 moles are given. 3 moles of hydrogens are given. Okay, actually requirement is 5.36, but the given is 4.96. So that's why the given amount is very less. So that's why hydrogen is a limiting reagent. Hydrogen is a limiting reagent. Okay, so first task will be completed from this identification of limiting reagent. So limiting reagent is a hydrogen is a limiting reagent. So hydrogen is a limiting reagent, that's why hydrogen can limit the amount of production of the ammonia. Okay, so that's why limiting reagent can limit the amount of product formation. So from this, that means limiting reagent can determine the amount of ammonia. Next one is calculated the ammonia formula. సో అందుకని అంటే అమోనియా ఫార్మేషన్ మనం క్యాలిక్యులేషన్ చేయాలంటే అది లిమిటింగ్ రియేజెంట్ యొక్క అమౌంట్ పైనే డిపెండ్ అయి ఉంటుంది. వి నో దట్ 3 moles ఆఫ్ హైడ్రోజన్ విల్ గివ్ 2 moles ఆఫ్ ది అమోనియా. ఓకే, ఇక్కడ చూడు 3 moles ఆఫ్ ది హైడ్రోజన్ విల్ గివ్ ది 2 moles ఆఫ్ ది అమోనియా. బట్ మనకి ఎంత ఇచ్చిండు ప్రాబ్లంలో? How much the limiting reagent is available? That is a 4.96 into 10 to the power of 3 moles of the hydrogen will be available. So ante 3 moles ki inta form అయినప్పుడు 4.96 into 10 to the power of 3 ki enta form అవుతుంది. Directly I will write the amount of the production of ammonia. that is 3.30 into 10 to the power of 3 moles of ammonia will be forming. Moles of ammonia, 4.96 into 10 to the power of 3 moles of hydrogen will give the 56.1 into 10 to the power of 3 grams of ammonia will be forming. Here this is a formation. Once again repeat it. 3 moles of hydrogen give the 2 moles of ammonia. So from this, how much the calculated? 4.96 into 10 to the power of 3 moles of hydrogen give how much? The 3.30 into 10 to the power of 3 moles of ammonia. So the moles are converted into grams. So we know that 1 mole of ammonia containing the 17 grams of ammonia. That means equal to. So now 3.30 into 10 to the power of 3 moles of ammonia containing the how much, or it is equal to how much the grams of ammonia. That is 56.1 into 10 to the power of 3 grams of ammonia. So these grams is also converted into kg. So 1 gram is converted into kg is nothing but 10 to the power of minus 3. 10 to the power of plus 3 minus 3 cancel. That's why here 56.1 kg of ammonia will be production. So this is a product formation. Okay. So once again repeat it. So 50 kg of, so finally we will write the 50 kg of nitrogen plus 10 kg of hydrogen reacted to form how much? The 56.1 kg of ammonia will be given. And the limiting reagent, so hydrogen is a limiting reagent. And the production of the amount of product formed is depending upon the limiting reagent. So this is the information about limiting reagent.